One of our standards in Math 3 is to be able to solve exponential equations and inequalities with tables and graphs. In this first example, we've got 4 times 2 to the x minus 14 equals 2. If you're looking at the graph, this part of the equation is where you see the red exponential curve. So that represents the function y equals 4 times 2 to the x minus 14. This part of the equation is your constant line that is blue going through the center here, and that's just y equals 2. So when you use the graph, think about putting one side into y1, one side into y2. You want to know when they're equal. So when they're equal is where they're intersecting. So I want to know for what x value are these two equal? Well, the x value there would be 2. So the answer is x equals 2. You can see that on the graph as well, because at x equals 2 is where the function has a y value of 2, which is what this right side is looking for. So when x is equal to 2, that exponential function equals 2 as well for the y. If you're looking at the inequality, it still has the same intersection point, but we're going to analyze the intersection slightly different. We want to know, when does the exponential function have a value that is less than 2? So we know it's equal to 2 when x equals 2, but when are the y values less than 2? If you look at your table, before we hit that intersection is where your y values are less than 2. So your solution would be when x is before 2, before the intersection point. Again, you can see that on the graph. When you want to know when the exponential function is less than 2, so less than would be underneath. So when are we underneath the line? Well, that's before the intersection point. That's before we hit 2. X is less than 2 would be your solution. In our next example, we're going to do something similar. We're looking at the exponential function y equals negative 1.3 to the x. Notice the negative is not receiving the exponent. And then plus 1, comparing that to equals to 4. So on the graph, we have y equals 4 as the black horizontal line, and we have the exponential function as the purple curve. Their intersection point is when x is equal to negative 2.642. So again, I plugged in one side of the equation into y1, that was my exponential function, and then I plugged y equals 4 as my second function. In the inequality, I want to know when the exponential function is less than or equal to 4. It's difficult to see it on the table because you're not going to see an exact intersection point since it is a rounded solution, but we get really close. So at negative 2.64, we are as close to 4 as we can get on the table. 3.999 is a little bit closer to 4 than 4.002. So this is where I would kind of start at my intersection point. But again, I don't want to know when I'm just equal to 4, but when am I less than or equal to 4. So after that point are the values that are less than 4. So the values that are after that intersection point would be when x is greater than or equal to negative 2.642. On the graph, again, you can see that we are less than 4 underneath of that horizontal line, so that is after that intersection point, which is why it's greater than or equal to.